Hi, good morning, everyone. For today, I'm going to explain about subtopic 1.3, force in equilibrium. Okay, we're going to move to our first slide. Okay, our first slide. Okay, learning standard. Okay, we're going to accomplish 1.3.1, explain force in equilibrium, sketch a triangle of force in equilibrium, solve problem involving force in equilibrium. Okay, in previous lesson, we already do our PBL, problem-based learning. I already asked you to complete 7 questions. Okay, depend on your group lah. Okay, you already know how to solve the problem. Is actually similar to our resultant force. Resultant force on its own. Okay, but there is a small difference lah. Okay, the difference for sure. We're going to investigate later. Okay, we're going to identify what is the differences between the resultant force and also force in equilibrium. Okay, what is force in equilibrium? An object is said to be in equilibrium of force when the force acting on it produces a zero resultant force. Okay, it focuses on the resultant force is equal to zero. The normal resultant force maybe the resultant force is not equal to zero. Fx component, force in x component is equal to force in y component and it's equal to zero. Okay, this topic is very interesting. Okay, because all the resultant force in y component and also x component is equal to zero. Okay, we're going to solve question number 1. Stationary lamp is hanging from 2 strings as shown in figure 1.24. Okay, this is figure 1.24. The tension is 12 Newton and the string is inclined at the angle of 60 degrees above the horizontal as shown. Find the magnitude of tension in the string. P and weight of the lamp W by using method 1, resolution of force, method 2, triangle of force. In order to find the magnitude of tension, we can solve it by using method number 1 and also method number 2. Okay, method number 1, as I told you before, we can resolve the force and make sure all the forces in Y and also X exist only. Okay, so we have tension here. Okay, it's in between exist Y and also exist X. Also, what we need to do is you have to resolve this force. Okay, the tension in order for you to solve this question, to find the magnitude of tension. Okay, we need to resolve this force into X component and also Y component. How to resolve the force? You have to do the triangle. Okay, so it's also easier for you if the angle is attached from the tension towards x-axis, we use cos. Okay, if the angle not touching y-axis, okay, y-axis, we use sine. Also, you can use, okay, this is right angle, so the total angle is 90 degrees. You also can use cos 30. 12 cos 30 is equal to 12 sine 60. Okay, so I think there is no problem for this question. Okay, we're going to look how to solve this question using triangle of forces. Okay, a stationary lamp is hanging. Okay, so method number 1, sorry, resolution of force. So you need to find total before we move to try method number 1. I'm sorry, method number 2. We're going to find the resultant force. Force in X component and also force in Y component. Okay, tension. Okay, as we see before, okay, we're going to find the tension is equal to Ty. 12 sine 60 is equal to weight. That means weight is equal to 12 sine 60. while the P, the force towards the right is equal to 12 sine 60. Why? Because the total forces is equal to 0. Total force in y axis and also x axis is equal to 0. Okay, that's why you already know lah. From this diagram, you can identify, you can determine the value of P and also W. Okay, it's easier. It's really easy, simple if you understand the concept. Okay. Okay, then P is equal to Tx, 12 cos 60 is equal to 6 Newton. W, weight, which is weight, is equal to Ty, force, tension in Y component, and is equal to 10.4 Newton. So we will proceed to how to draw triangle of forces. Okay, this is the tip. A triangle of forces can be drawn to show the equilibrium of three forces acting on an object. The magnitude of three forces are represented by the length of the side of the triangle, and they are drawn in sequence according to the direction of forces. Okay, so we need to make sure the magnitude and the direction of the forces is follow, ataupun you have to follow the scale. You need to reduce or you can increase the scale, but you need to make sure the direction of each forces is you didn't change any direction and didn't change any magnitude of the forces. But the tips is you need to create a triangle. Okay, I think you all know how to create the triangle. Okay, you need to identify the direction of forces. Okay, we have three forces here, and three forces. Okay, we have tension P, force to the right, and also W. Okay, you need to combine these three forces into a triangle. Okay, so W will be the pointing downward. P, you need to reverse the P backward. W, you put the W in order to connect the P and also P. Okay, so see, I didn't change any direction. P pointing 60 degree. Okay, 60 degree horizontally. Okay, sorry, 60 degree above the horizontal. Okay, 60 degree. Here, so you can see here angle is 60 degree lah. P, okay, force to the right, P. And you also have W, weight. Okay, W stand for weight pointing downward. I didn't change any direction. Okay, for triangle of forces, you need to use graph paper. As I told you before, you need to use graph paper, and it depends on your scale lah. Scale you can see in this example. Okay, they use 1 centimeter to 2 Newton. You also can use 2 Newton to 2 Newton, no problem, as long as it is fit to your scale graph ataupun to your graph lah. Okay, P is equal to 3 cm. That means P 3 centimeter. Okay, times 2 centimeter, and you akan dapat 6.0 Newton. Okay, W is equal to 5.2 centimeter. How you find this value? Okay, from the okay, you have to solve the question using resolution of force first. Okay, need to find 3.0 centimeter P, or you can okay, you need to resolve the force. Okay, you need to find the value. 3.3 times 2 Newton. You will find it 6 Newton, and W is equal to 5.2 centimeter times 2. You will get 10.4 Newton. You need to use the real value, from your diagram. Or for this question also, you can straight away measure from the diagram. Then you can use your scale to find the actual value. Okay. I hope you understand. Okay, we're going to proceed to question number 2. Okay, question number 2. Okay, this is the diagram. Okay, figure 1.26 shows a box of weight 50 Newton stationary. Please underline every time you read the question. Underline the important value or important statement. 50 Newton stationary on an inclined plane. Okay, you can see lah, it's inclined. Okay, sketch the free body diagram of the box showing the weight of the box W, normal reaction and also frictional force. Okay, by drawing a scale triangle of force diagram, determine the magnitude of normal reaction R and frictional force by resolving the weight of the box W into component parallel to the inclined plane and component perpendicular to the inclined plane. Determine the magnitude of normal reaction, also frictional force Fr. Okay, we see. Okay, we're going to solve question A first. Okay, you need to sketch the free body diagram. Okay, you need to resolve the force lah. Okay, free body diagram, that means, okay, in the question, they didn't show you any forces. So you need to find the forces based on the statement given here, weight of the box, normal reaction, also frictional force. Okay, it's normal for an object on stay on inclined plane, it will move downward. Is that correct? Okay, I think you all agree. Okay, but this statement state that the box is stationary. It shows that the frictional force is greater than the force forward. Okay, so frictional force, you have to know frictional force is always opposite your motion. Okay, so the direction of frictional force must be backward. Okay, so the weight always perpendicular ataupun pointing downward. This is the weight and also reaction force. Okay, there is one question. Okay, last time we solve problem. The question need you to draw the forces on an aeroplane. Okay, your friend they need to draw lah all the forces on the plane plane moving with constant velocity. Okay, constant velocity, that means the forces upward is not reaction for aeroplane. The force forward is not, force upward pointing upward, okay, from the aeroplane though, is not reaction force. Okay, reaction force only when the object stay on one place, there is a surface, normally on the ground lah, on the ground, on the table, on the anything else except plane. When you draw the force upward, it refer to what? Upthrust, okay, ataupun it's not reaction force, okay, is weight upthrust, lift force, not upthrust, force that move up forward, upthrust, drag force that drag the force ataupun frictional force lah, drag. Okay, the upward force we call as the upward force is the what I said just now, upthrust, lift force. Lift tu daya angkat. Okay, daya angkat upward. Okay, so the question is they already find the three forces. Okay, then you already managed to complete question A. 1, 2, 3. Okay, question number 1 done. Okay, by drawing a scale triangle of force, determine the you need to draw the scale triangle. Scale triangle, it will, okay, scale triangle, you need to know scale triangle, they will the size of the length of the line though, it will represent the magnitude of forces. Okay, it will represent, if the magnitude of forces is bigger, the line will be greater. Okay, then it will, you have to make sure your scale is correct. Then you will draw a correct triangle. Okay, we need to draw the triangle. How to draw the triangle? Okay, so we already know weight is pointing downward, frictional force pointing upward here. Okay, and we have reaction force here. Or you also can use this is the main part lah. Okay, this is the main part. Okay, the reaction force is upward. The weight is actually is not not parallel lah. Okay, this is the frictional force would be in x axis, the reaction force would be in y axis, and the weight is in between y and also x axis, y and x axis. Okay, this is your scale 1 until 5. Okay, it depend on your 50 Newton kan. 50 Newton we know lah, weight is 50 Newton. Okay, this is the scale triangle. The triangle, we know here is 40. How do you know it's 40? Okay, ni 40 kan. Zigzag. Zigzag. We know lah ni 40. Akan dapat sini 40. Okay, so next. Okay, so by resolving the weight of the box, okay, we need to know this is stationary. Force in y axis is equal to 0. Force in x axis is equal to 0. You need to solve. You need to resolve W because teacher already said just now. If the box is in inclined plane, you need to adjust lah. You need to adjust the diagram and make sure the R and also FR is in x axis, R is in y axis. So you need to resolve only W, weight. Okay, weight, akan dapat y sin 40. How will you get y sin 40? You have to draw the triangle. From the triangle before, you will find W sin 40 for x axis and y axis W cos 40. Dah dapat FR, frictional force is equal to W sin 40. R is equal to W cos 40. Easy. Okay, make sure you understand. Okay. Next is figure 1.17 shows a free body diagram of block sliding down a more smooth inclined plane. Normal reaction, block weight 60 degree. Scratch and label the component of weight of the block parallel to the inclined plane and the component of the weight of the block perpendicular to the inclined plane. Okay, you need to draw lah. You need to same goes to the question. This question is related, not related lah, similar to the question number 2. Okay, you need to find the main path. Okay, main path, that means the direction of the box sliding mesti towards downward lah. Ya kan, downward kan. Okay, so downward you akan dapat reaction will be in y axis and the friction tak ada. Kalau smooth inclined plane, that means there is no friction. Okay, no friction at all. Okay, unless it's said that the box is stationary and there is a frictional force. If the question didn't mention there is a frictional force, then you don't need to consider lah the frictional force into the solution punya method ataupun your solution. Sketch and label the component of the weight of the block parallel to the inclined plane and the component of the weight of the block perpendicular to the inclined plane. Okay, so we see here. Okay, same goes to the our previous example. Okay, you need to resolve the weight because weight is not in x axis, neither nor in x axis, not in y axis. Okay. Okay, so we have Wx here and Wy, 60 here. Make sure you know lah how to find the angle, how to use the correct angle. Zigzag, okay, dapat zigzag kat sini, you dapat 60. How you find dapatkan 60, dia right angle triangle kan, right angle triangle kat sini you akan dapat. Okay, Wx is equal to 20 sin 60. Okay, 20 sin normal reaction. Okay, the already already state that W weight is equal to 20, W sin 60 is equal to 17.32. Make sure you use 2 decimal places. Please don't leave your answer only 1 decimal places. Please 2 or 3. Normally untuk for this question we akan accept lah 2 or 3 decimal places. 1 decimal places consider wrong answer. Wy is equal to 20 cos 60 is equal to 10 Newton. Okay, resultant of the force perpendicular to the inclined plane. Okay, inclined plane. Okay, here your inclined plane, normal reaction. Okay, resultant force perpendicular to the inclined plane. That means y-axis. Normal reaction is equal to 10, and you get Wy is equal to 10. 10 plus minus 10 is equal to 0. Different direction, we consider it positive and negative. Resultant force on the block is equal to, okay, component in y-axis is equal to 0. Okay, Wx is equal to, tak ada frictional force is equal to 0, no frictional force, so Wx is equal to total force in x-axis. Okay, so resultant force on the block is equal to 17.32. Okay, so last question. Okay, figure. Okay, we need to, what is the acceleration of the block if its mass is equal to 2.2 kilogram? Okay, mass, acceleration F is equal to ma. Okay, your resultant force is equal to 17.32. Mass of the block is equal to 2 kg. Okay, find the acceleration F is equal to ma. Find the, substitute into the formula, then you will find A is equal to 8.66 meter per second square. Make sure you use the correct unit. Okay, thank you. That's all for today. Thank you so much. Stay well. Meet again for video lesson 1.4 elasticity. I'm working on it. Please make sure this is holiday. You use the time efficiently. Don't leave your book. Okay, make sure you use your read your book and do some revision. Sikit pun is okay. Okay, take care everyone. Okay, bye.